Welcome back, everyone. We will end up with end up the phase transformation chapter with some 2 to 3 numericals. So these numericals are very important. They're frequently asked in many of the competitive exams, such as GATE exams, and interview also they will ask these questions. Okay. So first question is estimate the number of the crystal-like clusters in 1 meter cube of a copper at its melting point for a spherical clusters containing 10 atoms, 60 atoms. It's a first part of the question. And second part is what volume of the liquid copper is likely to contain one cluster of 100 atoms. This is the second part. And the given data are the atomic volume of a liquid copper is 1.6 into 10 to the power of minus 29 meter cube, and the surface free energy of solid liquid interface is 0.177 joules per meter square, joule per meter square, and the Boltzmann constant is 1.38 into 10 to the power of minus 23 joules per Kelvin, and the melting temperature of copper is 1356 Kelvin. Okay, this is a given data. In some of the gate questions, gate papers, only one part. This is a part they will ask, or this may they can ask. That means in this question we have three questions, sub questions. Let's start with the solution. First of all, it's a spherical one. Spherical cluster we need to consider. For that one, number of the clusters can be given by the equation called as n equal to n naught exponential of minus delta g divided by kt. Correct? So this equation is a basic equation 1. In this one, we know n naught. So for 1 meter cube, n naught equal to 6.25 into 10 to the power of 19 atoms. Okay, and we know k, that is a Boltzmann constant. (23 joules per Kelvin), and we know T value, this is Tm. Okay, Tm we know that is 1356 Kelvin. Okay, so we don't know only the value of delta G. From the previous slides, it is very clear that delta G can be given as minus V into delta GV plus area into gamma of SL. At T equal to Tm, delta GV is 0. This can be like how it is this? Okay, I will explain. Delta GV is equals to GL minus GS. This Gibbs free energy of liquid minus Gibbs free energy of solid. These both are at equilibrium. GL equal to GS at T equal to Tm. Correct? Yes. That's why at T equal to Tm, delta GV is 0, then delta G can be reduced to A into gamma of SL. Correct? I will add one more white screen. Okay. As we know that A can be for sphere, surface energy is equals to 4 pi r square into gamma of SL, right? And we know that gamma of SL is given here and A 4 pi r square because of sphere. Okay. Then finally we have delta G is equals to 4 pi r square into gamma of SL. We don't know, here in this equation we don't know R value, so we will reduce that one also. This is equation 2. So before that one, the volume of the cluster is equals to 4 by 3 pi r square, sorry 4 by 3 pi r cube equal to NC into volume omega. I will explain. So NC is the number of the atoms that is containing each cluster, and it's the volume of the cluster that will give the total overall volume of the cluster. Okay, so from here I will write it, number of atom in a cluster, right? It's a volume of cluster. Okay, yeah. So from here we can reduce for the R value. So R can be given as 3 by 4 into pi NC omega whole divided by 1 by 3. 1 by 3. So substitute this R value in this equation. Delta G is equals to 4 pi 3 by 4 pi NC omega it's 2 by 3 because of square and into gamma of S. In this one we know this omega and these are all the things. So omega is given, that is 1.6 into 10 to the power of minus 29 meter cube, and we know gamma of SL. Then substituting these values write gamma of S also here for our reference 0.177 into joules per meter square. So substitute these two values here, then delta G can be given with the equation 5.435 into 10 to the power of minus 20 NC to the power of 2 by 3. Okay, so A option, NC given as 10 atoms per cluster. Okay, NC equal to 10 atoms, then delta GV can be given as 5.435 into 10 to the power of minus 20 into 10 to the power of 2 by 3, right? So substitute this value in equation, wait a minute, I will erase it. Substitute this delta G value in the equation 1, that is n is equals to n naught into number of clusters, NC is equals to n naught into exponential of minus delta G divided by KTM. Okay, then substituting these all the values, we will get NC as 9 into 10 to the power of 13 clusters per meter cube. Okay, similarly for B part, NC is equals to, sorry, this should be nabs for the differentiation. This is NC, right? Number of atoms per clusters. NC is equals to 60 atom. Then the NR, number of the clusters, is 3 into similarly for NC is equals to 60 atom, we will have I will write 3 clusters per meter cube. Okay, so we come to know that. So we will summarize first one. For NC 60 atoms, number of the clusters is formed is 9 into 10 to the power of 13, whereas NC equal to, sorry, for 10 atoms, and for the 60 atoms NR is equals to 3 clusters. So we can conclude that is with increasing number of atoms per cluster, the cluster number of clusters will reduce drastically. Correct? Yes. So similarly, so we can do second part, that is B part of this question, right? So do it and please write the answer in the comment box. Okay, so we will jump into the next question. This is related to the homogenization question. Calculate the homogeneous nucleation rate in a liquid copper at a undercooling of 180, 200, 220 Kelvin using the following data. They have given some data and we can need to calculate the homogeneous nucleation rate. Okay, so first of all, basic equation, homogenization nucleation rate, n homo is equals to n naught into exponential of minus delta G star kt. Okay, minus kt, right? This is the basic and fundamental equation. That's why we will consider as first equation, and we know that delta G star can be given as 16 pi by 3 gamma of SL whole cube divided by delta GV whole square. Delta GV can be given as L into T delta T divided by Tm. This is the equation. So N naught into F naught. This factor. Right? So substituting these all the equations, these two equations. Okay, I will make it as equation A and B, so that it will be very useful. This is equation A and this is equation B. Okay, so we are substituting equation A and B in the equation 1. Substitute equation A and equation B in equation 1. Then we will get as n homo as equals to F naught into n naught exponential of minus 16 pi gamma of SL whole cube Tm square divided by 3 into LV square into KT. Then we will term this is delta T in the other side. This is a varying parameter, right, that we have given, right? So this is delta T. This is the value, and here gamma of SL is a surface free energy is given 0.177 is also given, melting temperature is also given, and latent heat is also given. K is a Boltzmann constant, and T can be obtained with the help of from the delta t and the Tm value. We know delta t is t minus Tm. So, sorry. Tm minus t. Then the t value can be obtained Tm minus delta t. So from here we can calculate the t value, and so we need to calculate the rate of homogenization at different delta t value. That means different undercooling. So I have calculated separately and substituted those values, and I have calculated. I will give the direct answers, and please substitute and get the values. Delta T in Kelvin is given as 180, 200, 220. N of homogenization, this is per meter cube per second, is given as 0.7, 8 into 10 power of minus 6, and 1 into 10 power of 12. This is the final answer. So as we are increasing this trend, we can write the conclusion. As we increases delta t, rate of homogeneous nucleation will also increases. This is the final conclusion that we are from this problem. So please substitute the values and be familiar with the calculators, so that it will be helpful for your and some exams also. Right? We'll get into the next question. This is a GATE 2017 question that I have selected. For homogeneous nucleation of a solid in a liquid of pure metal, the critical edge length in nanometer of a cubic shaped nucleus is. He is asking. So here I have chosen, this is the nucleation may be any shape. It may be sphere, it may be cubical, it may be rod, it may be plates or rectangle, any shape it can be. So that's why. So I have chosen this is because of this is a cubical one, and we need to find the critical edge. It is similar in the case of the spherical one. In spherical we need to calculate the critical radius. Here we need to calculate the critical edge. This is a cube. Cubic nucleus. Nucleation that has been taking place in the liquid of a pure metal. Need to calculate the critical. L star. Need to calculate. For that one, so basic equation, we know that X is free energy, delta G is equals to minus V divided by delta GV plus gamma of solid liquid into surface area. For the cubic, a volume is given as a cube, or I will consider this as a star. Okay, so it will be useful for me also. This is a star, that is a cube, and the area is given as 6a square, surface area. Substituting these two values in the above equation, then we will get it as delta G is equals to minus a cube into delta GV plus 6a square into gamma of SL. Okay, so if we want to calculate the a star value, that is a critical value, then we have to differentiate this equation with a, then we will get a critical value, right? Is dA is given as 3a square into delta GV plus 12a square 12a into gamma of SL, okay, is equated to 0. Then 12a gamma of SL equal to 3a square into delta GV. So this a get cancels, and 3 ones are 3 fours are 4 gamma of SL divided by delta GV is a star value. So next step is very easy, that is a substitution and get the value for a star. Correct? We know delta GV value and gamma value, both we know, and substitute and get the value for the a star. Correct? The a star value, I will give the answer for you. A star is almost 2.528 nanometer. So see here, so this is the very basic mistake they will do in the GATE exam, that is he has already asked about in nanometers, so need to add, but he has given the data in a meters. First do all the calculation in meters, and finally you just calculate, you will get it as 0.2528 into 10 to the power of minus 8 meter you will get. So then afterwards you need to convert it into the nanometer, that is 2.528 nanometer. This is a basic equation. This is a 2 marks and it will take only hardly of 1.5 minutes to 2 minutes if you have practiced well, and it's very easy question, you can answer very easily. So these type of questions very frequently asked in GATE, so that you can answer well, and so that's why I have covered this topic. Thank you. Thank you everyone. So if you have any doubts regarding this one, any questions, please mail me in this mail address and we will discuss. If you need any topics, so for the further discussions, or if you are not cleared any topics in the explained in this phase transformation series or any other else, iron carbon diagram, anything else, you just mail me or write it in a comment box section so that we can discuss very easily. Okay, thank you.